Every year, Avery School has a fair. This year, 3/8 of the booths have face painting, and 1/4 of the booths had sand art. Were there more booths with face painting or sand art? So now we need to compare two fractions with different denominators. Are these easy to compare in your head? Can you visualize these in your head and just say, oh, I know what that looks like? Some of you may be able to do that, and some of you may struggle with that. And we're going to go through how to do that because you can compare these. How many of you would like to go with this one because the numbers are bigger? That this is more. 3/8 is more. Okay. If you're looking at it and you think the 3 is more than the 1 and the 8 is more than the 4, that's wrong thinking. So don't think that way. Okay? That doesn't mean that's not the right answer. It just means that you can't look at the numbers individually and decide, hey, that's a bigger number. Okay? So let's look at the first way that they're showing us how to do it. It says, when two fractions have the same denominator, they have equal size parts. Right now, are they equal size parts? No. These are 8ths. They're smaller. These are 4ths. They're a little bigger. So we want to make a common denominator. Is there a denominator that both 8 and 4 can share? What is it, Sophia?
2.
They both are divisible by 2, but we're looking for a denominator that they can both have. What do you think, Andy? 8. Okay. So first of all, we already have one of the fractions is in 8ths. How many 8ths here? 3/8. So that's the first one. The second one we need to turn into 8ths. So we take the 1/4 and we multiply. We're looking for 8ths, so we have to multiply the bottom number by 2. So the denominator gets multiplied by 2 to get the 8. So what do I multiply the numerator by?
2.
2 times 1 is 2. So now I have my other fraction with the same denominator. Now it's divided into 8ths. They have a little visual for you. If you go ahead and shade them, this one's 3/8. You can go ahead and do yours. And this one is 2/8. Go ahead and do yours real quick. Looking at this, which number is greater? Which fraction is greater? I need to see people looking up here. Which one, you guys?
3/8.
3/8. You can see that that's a bigger piece. If these were brownies and you really like brownies, which one do you want to eat? 3/8, because there's more of them. Okay, so another way is you can use a common numerator. Have you ever heard that before? Does that make sense?
Yeah.
Let's see how that works. When two fractions have the same numerator, they represent the same number of parts. And then you can compare the size of their parts. Remember, if you have, let's say you had 3/2 of something. Can you visualize what 3/2 look like?
Yes.
2/2 is how much?
3.
1 whole, and another half is a half. So you would have a whole and a half of, let's say you had 3/2 of a cookie. If she gave me a half, and he gave me a half, and he gave me a half, I really have a whole cookie and a half. Okay, so 3/2. What about 3/4? Is that even a whole cookie? So I can look at these and they have the same numerator, but their denominator is different. I can say, well, these are smaller pieces. So I know that's a smaller amount. Okay, so I'm going to go through it though real quick. So I just barely started. All right. So 3 is a multiple of both 3 and 1. So we're going to use the 3 as the common numerator. Because can we change this 1 to a 3?
Yes.
By doing what to it?
Multiply times 3.
Multiply by 3. So 1 times 3 equals 3. 4 times 3 equals 12. I need more participation. I have some people kind of on zone out mode. Okay. So I've now changed my 1/4 to 3/12. I'm using my 3/8 still because I wanted to keep the numerator the same. And now I'm going to shade my model 3/8 and 3/12. Go ahead and do yours. All right, we have a model to look at. Looking at the model, can you tell which fraction is greater?
Yes.
What is it?
3/12.
3/8 is greater. See this right here? I can tell that this is a bigger amount than this. So visually, I can see that the 3/8 is a larger amount. If I don't have a model in front of me and I have the same numerator, I can look at the denominator and know that a larger number means smaller or larger parts? Smaller. So the larger the number gets, the larger the number gets, the smaller the parts. Right? So in this case, we start with our 8s are pretty big pieces. Looking at me? Our 8s are pretty big pieces. Our 12s, not as big, are they? So again, if you're dividing a pizza, let's say you have a pizza for, and you want them, and you each get to have a piece of pizza. Would you rather have a piece that's the size of a fourth of the pizza or a piece that's a 12th of the pizza? A fourth, because you know that those fourths are bigger than the 12th pieces. And it's this, so that's the same concept. Think of pizzas, okay? The larger the piece gets, the larger the denominator gets, the smaller the piece gets. All right, since 3/8 is greater than 1/4, there will be more booths with, so I have to go back up to my question. 3/8 was talking about the booths that had what? Face painting. Okay, so compare the fractions and explain what you did to figure it out. So in this case, I have 3/4 and 1/3. We can change the denominator or we can change the numerator. How many of you would like to change the denominator? How many of you would like to change the numerator? Okay, so let's do denominator. So what is a common denominator for fourths and thirds? Preston? 12ths. So this one, to go from fourths to 12ths, I have to multiply by,
3.
your pencil should be down, and you should be paying attention. I have to multiply by 3, so I'm going to multiply the numerator by, what is that?
12.
9. Okay, the next one, the 1/3, I'm going to change to 12ths. To get from 3 to 12ths, I multiply by 4. So I multiply the numerator by 4 and I get 4. Which number is greater? Which one of these is greater? This is greater. So then is 3/4 or 1/3 greater?
3/4.
3/4. Okay. And then it says to explain your reasoning. So we have the same, I'm going to make this shorter since my pen's all fat, same size parts, right? The size of the parts is 1/12. So we have the same size parts. The 9 is more parts than the 4, right? So that's why that works. The 9 is more parts than the 4. Now think, remember if you're eating pizza, if it is split into 8 parts, or it's split into 5 parts, which one of those parts are bigger pieces? The 5/5 or the 8ths? Not, I'm asking the 5ths or the 8ths, not 3/5 or 3. Which, if you have a pizza, listen to the question again. If you have a pizza and it's cut into 5ths, and you have another pizza that's cut into 8ths, which pizza has the bigger pieces, the 5ths or the 8ths? Go ahead and think for a second. What do you guys think?
The 5th.
The 5ths. So, now if you have 3 of those 5th size, and you have 3 of the 8th size, which one of those are going to represent more pizza?
3/5.
The 3/5, because they're bigger pieces. So if you have 3 of those pieces are bigger than these 3 pieces. So then our 3/5 is greater than 3/8. Who thinks they can give us an explanation? Why don't you go ahead? I'm going to give you a second to explain that in words, like we did on this one a minute ago. Explain in words how we just did that. Okay, why don't we go, Lydia? Nice and slow so I can hear you. So she said you cut a pizza into fifths, and you cut a pizza into eighths, and then you take 3 pieces of the fifth size, and you take 3 pieces of the eighth size, and the 3 of the fifths are larger. Okay, Luna. Which one of those looks like the friendly number to play with? The denominator or the numerator? The denominator. Why did you, who would like to explain to me in words, why did you pick the denominator to play with? Ethan. You can multiply 4 times 2 and get an 8, and then you would have a common denominator. So are we going to do anything with this number?
No.
No, because it already is 8s. To get into 8s here, I had to multiply by what class?
2.
2. So I'm going to do multiply the numerator. I know you guys are tired after lunch. Numerator by 2, so 3 times 2 is 6. Now can I compare those two numbers?
Yes.
Which one is greater?
7/8.
7/8. Go ahead and write an explanation. Looking at this one. Looking at this one here. What is going to be a better choice to work with, the numerator or the denominator?
Denominator.
You can do either one, so there's no right answer of which one you have to do. But I'm looking at it and I'm thinking the 2 times 2 is going to equal 4. So I can make my numerator the same and then compare the size of the pieces. Okay? So if I'm going to change the numerator, do I need to change this fraction?
No.
No, because it's 4, and I'm going to change this one so that this numerator says 4. In order to change this numerator to say 4, what do I have to multiply by?
2.
2. So now I multiply the denominator by 2, and I get 3 times 2 is, so it should be 4/6. Go ahead and write 4/6 on your paper. Which one is greater? 4/6. I want you to think. Hold on. Is 4/6 greater or 4/5? Think about the size of the pieces. What are the size of those pieces, and which one will be greater? I want you to raise your hand when you think you know. So you're saying that 4/6 is greater? 4/5 is greater. Why is 4/5 greater? Okay, so he said that this one is larger because the bigger the denominator, the smaller the piece. And if you have 4 of these pieces and 4 of these pieces are smaller. So this has to be the larger number. Okay, go ahead and write your little explanation. What would you use to compare 11/12 and 5/6? Would you use common denominators or common numerators? Raise your hand when you have an idea, and I should see a hand from everybody. So would you decide on common numerator or common denominator for this one? Raise a hand when you have an idea. Look at the numbers. 11 and 5, do they compare easy? 12 and 6, do they compare easy?
Yes.
Okay, which one did you guys choose?
Denominator.
The denominator is more friendly, and that's it. The explanation says it says to explain. And I personally, if I was writing it, I would say that I would choose common denominators because the denominators are more friendly to work with because I can multiply 6 times 2 and get 12. If I do common numerators, I got to go to 55. That would be my common numerator. That's the first common numerator for 5 and 11. 55. So that's a whole lot of unnecessary multiplying, isn't it? Because that would be 50 like this. So 11 times 5, so I'd have to do 12 times 5, and then this was 5 times 11 equals 55, so I'd have to do it like this. Doesn't that seem just so unnecessary? Yeah. So it's easier to keep the 11/12 and make this 10/6, and now I can compare them. Which one is greater? I'm sorry, 10/12. Which one is greater? Can you use simplest form? I want your pencils down. Can you use simplest form to compare 8/10 and 3/5? Which one is not in simplest form?
8/10.
8/10. What is the simplest form of 8/10, Preston? 4/5. Remember, to go from 10 to 5, we would just say divided by 2. So then we do the top one divided by 2, which is 4/5. So can we use simplest forms to compare these? Simplest form to compare those two numbers. Number 1 says compare 2/5 and 1/10. They've decided for you that you should use a common denominator. And what would the common denominator be that we should use for 2/5 and 1/10? What do you guys think we should use as a common denominator? What do you think, Ronnie? 10, right? Because 5 can go into 10 and 10 can go into 10. So they brought down the 1/10 because you don't need to change that. If you're struggling, make sure you're paying attention. And now I need to change the 2/5 to 10ths. I know that I want my answer to have, my result to have a 10 on the bottom. So I'm going to take my 2/5. I'm going to multiply the 5 times what number to get 10? 5 times 2. So if I multiply the denominator by 2, I have to multiply the numerator by 2. 2 times 2 is 4. Okay, so now I'm comparing 4/10 and 1/10. And if I set it up the same way here, they have the 1/10 here, this really is 4/10, right? Which one is greater? 2/5 or 1/10? Which one's greater?
2/5.
This one is greater. I can tell because it's really 4/10. And this is 1/10. And I know that 4 is more than 1. Okay? Number 2. It says to use a common numerator. So we have 6 and 3 as numerators. What common numerator should I use? Haley. If I have a 6 and a 3, what common numerator should I use? 3 goes into 6, but 6 doesn't go into 3. So I could use 6. There you go. Okay. So we're going to use the common numerator of 6. This number, we don't have to, this fraction, we don't have to change because it's already 6/10. We want this 3/4 to turn into 6 something, to be changed to 6 something. So 3 times what number equals 6? 2. So if I multiply the numerator by 2, I have to multiply the denominator by 2. 4 times 2 is 8. I have 6/10 and this is 6/8. These are smaller pieces. These are bigger pieces. Which fraction is greater?
6/8.
How many of you agree with that? That 6/8 is greater? Okay, it is greater. So then that means that the 3/4 is greater than 6/10. Now, just looking at 7/8 and 2/8, do I have to change anything?
No.
Who could explain to me in words why I don't have to change anything? Malia, why would I not have to change it? Right, because it's a common
Denominator.
They already have a common denominator, so which one is greater?
7/8.
Okay, do I need to change anything on 4?
Yes.
I want you to look at it and make a decision. Do you think it's better to change the denominator or the numerator? I want you to think first. Should I be looking for a common denominator or numerator? Raise your hand when you know. Okay, so we are going to change the numerator, but is it the denominator that we're going to make common, or are we going to make the numerator common? The denominator is going to be common. So this one we're going to keep as 5/12, and we want to make this one 12. What do I multiply the 6 by to get to 12?
2.
2. So I multiply the numerator by 2, and I get
6.
6. And now I can compare 5/12 and 6/12. Which one's greater?
6/12.
6/12. Looking at number 5. Do I need to change anything?
Yes. No.
Okay, I'm getting mostly no's. Sean, explain to me why I don't have to change anything on number 5. What's the top one called?
Numerator.
Numerator?
The numerator are both the same.
Right, so the numerator's the same, so we can compare the size of the parts. Which one has larger parts?
4, 6.
I got Brian's awake over here. 4, 6 is greater pieces. The parts are bigger pieces. And we have 4 of those. We have 4 of the other ones, but these are bigger pieces. All right. Number 6, you can pick either. Pick the numerator or the denominator. Make it common, compare them, and then raise your hand. I'm going to show you what's happening. Most of you are changing this fraction. So if I didn't approve you yet, pay attention. We're changing this fraction to 12ths. Most of you got that. How did I change this 4 to 12? I did what? Okay, if I've already approved you to go on, go on.
Yeah.
If I haven't approved you, I want you paying attention. Did I not approve you yet?
No. You haven't checked on yet.
So I multiply 4 times
3.
3. If I multiply the denominator by 3, I have to multiply the numerator by 3. 2 times 3 is?
6.
Okay, so how many of you that I went by and you have this, but then you did something like this? Tell me what's wrong with my work here. How come I can't do a greater than like that? Aaron.
Because you can't compare 6, 12 to 6, 12.
Well, I can. How do they compare? I can't. I know what you're trying to say. They compare. How do they compare? Is this one greater than this one?
No.
Is this one greater than this one?
No.
Are they, what are they then?
Equal.
There we go.
I knew it.
That's it. So most of you already had the 6/12ths. You already figured out the 6/12ths for this fraction. But you're missing the equal, that this equals that thing. Can I tell you what Nicholas did? He did something completely different. I didn't even see it until he did it. Simplest form. 6/12ths is if I divide it by 2. Both of those numbers are divisible by 3. 6 divided by 3 is 2. 12 divided by 3 is? Actually, you know what? I can go even better. 6 goes into 12. 6 divided by 6 is?
2.
6 divided by 6? 12 divided by 6. 2 divided by 2? 4 divided by 2.
2. Oh, wow.
So you can also do simplest form. You don't have to do...
You don't have to always do the